Welcome to Lubricant World's YouTube channel. Today we have gathered here for the webinar on energy efficient hydraulic fluids in industrial equipment. Energy efficiency is one of the most important topics of this era. Evonik Oil Additives, founded in 1907, is a pioneer in this field with its knowledge and experience. Evonik, a leading German company which is an expert in the field of efficiency, indicates that it is possible to achieve a great energy efficiency by using the right hydraulic fluid in industrial equipment, and to decrease the cost while minimizing the environmental impact thanks to the productivity and performance benefits such products offer. Today, Dr. Holger Pletsch is here with us to share his valuable information about the subject. I would like to thank Dr. Holger Pletsch, Technical Service Manager at Evonik Oil Additives, for accepting our invitation to speak at this webinar. Before giving the floor to Dr. Pletsch, I would like to tell you that we as Lubricant World are quite excited to hold our first bilingual webinar. You can follow our subtitles in English and Turkish. You can also view the presentation in Turkish by clicking on the link below the video. Dr. Pletsch, we are going to talk about hydraulic fluids, contribution to energy efficiency. Well, how these fluids make us save energy? What kind of technology makes it possible? Can you please enlighten us? The floor is yours.
Thank you very much, ladies and gentlemen. First of all, I would like to express my gratitude to Selçuk Akert for inviting me to speak in this webinar today. And I welcome all of the participants to the webinar, Energy Efficient Hydraulic Fluids in Industrial Equipment. During the next 30 to 45 minutes, it is my goal to explain how hydraulic fluids can save a significant amount of energy costs, so that at the end of the session, you will have a fair understanding about the savings potential as well as about the technical principles behind. But first, please allow me to introduce myself. My name is Holger Pletsch, and I'm speaking to you today as a representative of Evonik Industries. Evonik is one of the largest German chemical companies with a diversified B2B product portfolio and a worldwide network of production sites and research centers. One of Evonik's focal areas are specialty additives, such as viscosity modifiers, anti-foam additives, antioxidants, cross-linkers, and many, many more. Just to name a few applications, you can find Evonik products in coatings, in adhesives, in plastics, and last but not least, of course, also in hydraulic fluids. Typically, the additives make up only a very small fraction of the oil formulation, but they do have a big effect on performance. But before going into any details, allow me just to say a few words about myself. When I joined Evonik in 2015 as an innovation manager, I was responsible for extending the product portfolio of the Evonik Oil Additives division. And since 2018, I'm a customer relations manager with a focus on technical aspects and with a focus on the Turkish market. Due to the coronavirus situation, business trips and face-to-face events have been canceled, and home office has become the new work style also for many Evonik employees, including myself. So therefore, I'm very glad to have the opportunity to speak to you today about energy efficient hydraulic fluids in this webinar setup. By the way, some of the key principles that I'm going to talk about today are also explained in an article in the Lubricant World magazine issued on the 13th of November 2018. Energy efficient hydraulic fluids are becoming more and more important and also more and more available on a global scale. It's not only the trend towards sustainability, but also very fundamental cost considerations that make those kinds of hydraulic fluids very attractive to the end user. And I must admit, at first sight, it may seem illogical that energy-efficient hydraulic fluids can provide financial benefits to the end user simply because they are generally slightly more expensive than conventional hydraulic fluids. But I will demonstrate you today that the savings in energy, fuel costs will overcompensate the additional fluid costs. It's one of my most important targets for today to demonstrate you that the energy or fuel savings are first of all proven in the field, and second, that they are applicable for various hydraulic applications. So first we will take a look at the technical principles behind energy-efficient hydraulic fluids. And then we'll switch from theory into the real world and look at performance demonstrations, both in manufacturing equipment, or to be more precise, in injection molding equipment, and also in construction and mining equipment. In the end, we'll also run through a business case. It is the target of this session to learn how to save diesel fuel or electric power with energy-efficient hydraulic fluids and how to reduce the total cost of ownership. So now let me briefly review what are the typical roles and properties of hydraulic oils in industrial equipment that we typically think of. So obviously hydraulic oils are supposed to transfer pressure, but there are other important factors that are very decisive in the selection of an hydraulic oil. So for example, the oil needs to protect the equipment. The oil needs to reduce friction and wear. The oil needs to dissipate the heat, especially under high load conditions. And then there are some applications under extreme environmental conditions that would require even more specialized properties, such as stability against water or biodegradability. Efficiency and productivity increases are typically, however, not associated with the hydraulic fluid. And in fact, the majority of hydraulic fluids on the market do not provide any efficiency or productivity benefits. Only dedicated fluids will bring you this benefit. But how much benefit can you really expect? Depending on the application we are talking about, a 2-digit efficiency increase is plausible and proven in the field. Compared with conventional hydraulic fluids, energy-efficient hydraulic fluids will save up to 20% of fuel in construction or mining equipment and up to around 10% of energy in stationary manufacturing equipment. Of course, we have to understand that different applications have substantially different requirements. And today I would like to concentrate on stationary equipment on the one hand, and mobile equipment on the other hand. Stationary equipment in manufacturing typically runs at much lower operating oil temperatures than construction or mining equipment. But nevertheless, the oil has to handle peak loads and peak temperatures, and it typically has to operate under 24/7 conditions. Any equipment failure, any interruption is a critical concern for the equipment owner. So therefore, long oil drain intervals are favorable and would maximize the possible output. Because of the 24/7 operation, energy typically is one of the biggest cost position to the users of manufacturing equipment. Looking into mobile equipment, on the other hand, we can conclude that the environmental conditions are much more demanding. So typically excavators will need to handle cold start conditions in the mornings and high load, high temperature conditions during operation. Overheating is a serious problem and will lead to productivity deficiencies. in general, a high productivity and high fuel efficiency, of course, are some of the main concerns and main interests of mining end users and also construction end users. And we'll see that the selection of the right hydraulic fluids can contribute to improving efficiency and productivity. So in the next 5 to 10 minutes, I'm now going to talk about the principles behind energy efficient hydraulic fluids. And we'll clarify the question, how can hydraulic fluids improve the energy efficiency of a hydraulic system? The simple answer to this question is we need to exert control over the viscosity of the hydraulic fluid. Viscosity is the fluid's resistance to flow, and we can also call it thickness of the fluid. A fluid with a low viscosity, for example, is water. A fluid with a high viscosity, for example, is honey. And by instinct, I bet we would all agree that it requires more energy steering a glass of honey than steering a glass of water. So we already know that the high viscosity of the honey has a consequence on the energy that we need to invest to steer the honey or the water. Cross-reading to our application in hydraulic systems, does that mean that the viscosity of the hydraulic fluid must be as low as possible in order to maximize the energy savings? It may come as a surprise now to you, but the answer to that is no. In fact, a viscosity compromise is required to maximize the energy saving ability. Again, let me make this point once more. A well-balanced viscosity is the key for energy efficiency, because only then we can minimize both the hydromechanical losses and the volumetric losses that we observe in every hydraulic system. Having said that, we can also conclude that any fluctuations in viscosity need to be avoided as much as possible during operation. And now, together with you, I want to analyze where viscosity fluctuations are coming from. There are basically two sources. The first source is the variation in operating temperature. The higher the oil temperature, the lower the viscosity, and vice versa. That's pretty straightforward. The second root cause is less straightforward, but it also will affect viscosity fluctuations, and that's oil aging. The longer you're using the oil in operation, the more it will change its performance. Viscosity losses can be observed because the shear stress in the hydraulic system is physically destroying components in the hydraulic fluid. So shear stress is just another word for pressure gradient. And as you know, in hydraulic systems, the oil typically operates at the interface between very high and low pressure, so the shear stress is high. On this slide, I will give you a guideline how you can identify those hydraulic oils that avoid viscosity fluctuations as much as possible. The first indicator is the viscosity index, or short VI. The VI is a measure to describe the relationship between temperature and viscosity of the oils. So the higher the VI level, the lower is the viscosity fluctuation. And at the same time, a high VI fluid will also have lower start viscosities. That means improved resistance against cold temperature conditions. And last but not least, the higher the VI, the lower the risk of overheating. To give you some numbers, a conventional hydraulic fluid has a VI of around 100. An energy efficient hydraulic fluid has a VI of at least 160, or better 170, or even better higher than 180. So this should serve you as a basic guideline when you look out for energy efficient hydraulic fluids. The other factor that I described is shear stress. We can avoid viscosity fluctuations if we design the fluid in a way that it can resist shear stress as much as possible. In other words, the higher the shear stability of the fluid, the better. And this is the second indicator that you can look out for when purchasing energy efficient hydraulic fluids. Of course, the statements that I just made about viscosity index and shear stability are based on experiment. There's plenty of data, both from the laboratory and from the field, that prove the relationship between VI, shear stability, and hydraulic efficiency. We will come to the field data in just a second, but let us first review the laboratory data. So what you see here on the slide is an efficiency test using a Denison vane pump at fixed conditions. 6 fluids were tested, 3 with a relatively low VI of 150 on the left-hand side, and 3 with a very high VI of 200 on the right-hand side. Each of the fluid either had a poor, a medium, or an excellent shear stability. And you can see that both factors, the VI and the shear stability, are contributing to the increase in efficiency in a significant way. Now, before I will demonstrate you that we see the same effects in the real world as well, let me briefly emphasize that energy efficient hydraulic fluids will also be able to pass the most demanding durability requirements of certain OEM specifications. One of the most important OEM specifications certainly is issued by Parker Dennison. The key element of this specification is an extensive pump test with a hybrid pump rig. Only highly shear stable hydraulic fluids can pass this pump test. And same holds true for other OEM specifications, such as issued by Bosch or by İçin, for example. The respective pump tests differ from each other, but they do have one thing in common. Once the hydraulic fluid is approved by one of these OEM specifications, the fluid has a guaranteed protection against wear and corrosion. But now let me switch gears again and stop talking about durability and come back to efficiency. At the beginning of this webinar, I promised you that I will demonstrate you that we can prove in the field, in the real world, that the concept of energy efficient fluids really works. And I will now guide you through our experiences with injection molding, and afterwards I will do the same with construction and mining equipment. First of all, I'd like to emphasize that the performance demonstrations are done according to a very strict test protocol. So the test protocol intends to minimize systematic errors during data acquisition. And for example, the test protocol will define that a reference fluid needs to be tested, and the reference fluid needs to be tested as a first fluid and as a last test fluid. It also defines the flushing procedures, the oil change procedures. It defines the types of oil quality checks, the intervals of oil quality checks, and it, of course, also specifies the test conditions. The data acquisition itself is done using highly sensitive test devices, and after the data has been collected, the data set is probed for statistical significance by a team of mathematicians. Because these guidelines are strictly obeyed, we can guarantee a representative and reproducible test result. The energy efficiency improvements were in fact proven on many different machines and under many different conditions. So here you can see a selection of performance demonstrations on Boy, on Engel, Husky, Haitian, and Krauss-Maffei equipment. The smallest machine in this test set is the Boy 35E, and by far the biggest machine is the Haitian machine. And you can also see that different operating temperature ranges are covered in our tests. And The duration of the performance demonstrations mostly were in the range of some weeks, except for the field trial on the Krauss-Maffei machine that was covering a test duration of 1 entire year. In each of the cases, we probed an ISOVG 32 energy efficient hydraulic fluid. That means a fluid with a very high viscosity index of around 185 in comparison with the conventional ISOVG 46 monograde hydraulic oil. In general, we found energy saving potentials of up to 10 to 11%, while the average savings potential lies somewhere around 5%. So in summary, you can expect that this energy savings are statistically significant and also reproducible under many different conditions in injection molding. Okay, now allow me to switch gears again and take a look at field trials in excavators used for construction and mining. Excavators typically operate in highly dynamic environments. The energy efficiency of an excavator is depending on different factors, for example, on the work cycles and on the type of material that is moved. So for example, it makes a difference if the excavator handles just loose gravel or if it handles big rocks, and certainly heavy loads such as big rocks are more demanding to handle for the equipment. And also the weather conditions play a role. So remember that overheating of the hydraulic system leads to losses in efficiency and productivity. To account for all these dynamic conditions and to make the field trials as comparable, as reproducible, and as relevant as possible, our engineers pay sincere attention to minimize some of the most important influencing factors. For example, the respective field trial is done with the same excavator machine, operating with the same test work cycles, and we even make sure that we have the same operators over the time frame of the trial. And of course, we accurately document key parameters such as the oil temperature, the working hour protocol, and of course also the fuel consumption. Together with statistical data analysis, the test results can be regarded as highly accurate and reliable. So here I brought you 4 examples out of the many field trials we have conducted so far in excavators. Note that we are always comparing an energy efficient hydraulic fluid with a conventional monograde hydraulic fluid of the same viscosity grade. And let me start on the left-hand side with explaining the first example conducted in Germany. In a road construction environment, we compared the 2 fluid types using a crawler excavator. The fuel savings in this case were reported to be up to 15% during normal use and up to 25% during stone milling. In the second example, we were testing in a sand mine in Lithuania. So mines typically operate in 24/7 shifts, but here we are talking about a day shift application. The tested equipment was a mobile sand sieving unit. And again, we compared energy efficient type hydraulic fluids with a conventional hydraulic fluid of the same viscosity grade. A diesel fuel saving potential of 3 liters per hour was determined. And it was further reported by the mine operators that the cold start behavior had improved with the energy efficient hydraulic fluid. As you remember, this goes back to the high viscosity index of the fluid. High VI will guarantee lower viscosities at low outside temperatures and higher viscosities at high temperatures, or short, less temperature-induced viscosity fluctuations. The third field trial was done in the recycling industry, where excavators are used to transport different types of waste materials from one place to another. The operators in that case had complained about overheating issues with the conventional hydraulic fluid. Overheating is not only detrimental to the fuel consumption, but it also decreases the productivity of the hydraulic equipment. Overheated equipment can't be used, and the workers are forced to take a break. In the interest of productivity, overheating is, of course, better be avoided. With the energy-efficient hydraulic fluids, the overheating problems were solved. On top, a 2 liters per hour diesel saving was reported. Last but not least, another example of 10% fuel saving in a crawler excavator used for digging and material handling in an Italian pipeline job. So in total, you can expect that energy-efficient hydraulic fluids can deliver around 10% fuel saving potential at least. It is not uncommon that the fuel saving is even higher than 20%. The equipment is proven to be better capable of handling both cold start conditions and high temperature, high load conditions. In other words, the risk of overheating is reduced and therefore productivity increases can be expected. In the last part of this presentation, I would like to detail a business case for energy-efficient hydraulic fluids. To do that, let's assume a construction equipment application such as a crawler excavator. I will now further assume some of the boundary conditions. The first being the cost of diesel fuel. In Turkey, the diesel price is something around 6 lira per liter at the moment. That's around 71 euro cents. The second assumption is the cost of the conventional hydraulic fluid. A typical price is €1.10 per liter. That's around 10 lira per liter. Obviously, as I said, the price of the energy-efficient hydraulic fluid is slightly higher than the price of a conventional hydraulic fluid. The technology behind simply is much more sophisticated and the formulation is very well balanced, so the increased fluid costs are justified. Let's assume a price of around €1.70 per liter. That's around 15 lira per liter. Let's assume the end user operates 30 machines at a fluid drain interval of 2,500 hours. And the fluid changeout volume in that case is 700 liters. So we're talking about a mid-sized or large-sized excavator here. For the business case calculation, we are assuming a very conservative 8% efficiency increase, as well as a 25% increased oil drain interval. Within the time frame of one oil drain interval, the energy-efficient hydraulic fluid will generate fuel savings of around 88,000 euro for the 30 machines. That's around 770,000 lira. Because the oil drain interval is extended, another 7,000 euro savings come on top. That's around 60,000 lira. For sure, as I said, there is an investment in the fluid. The fluid itself is more expensive, and this accounts for an additional 12,600 euro investment. That's around 110,000 lira. Bottom line, the total savings will be around 80,000 euros. That's around 730,000 lira within the time frame of one oil drain interval, in this case, 2,500 hours of operation, and for 30 excavators. On the right-hand side, you can see that the initial cost of investment of 12,600 euros are overcompensated after only 154 hours of operation, and that the return of investment is around 8 times the investment itself in this scenario. Now, this is just one scenario, and for sure, each case is different. But based on our experience in the field, in many different applications, under many different conditions, and with a wide variety of hydraulic equipment, we are sincerely convinced that the investment will pay off in any case. Okay, allow me to summarize. The key advantages of energy-efficient hydraulic fluids are lower energy or fuel consumption, longer oil drain intervals, reduced risk of overheating, and better cold start behavior. As a consequence, you can expect savings on your energy costs, reduced maintenance efforts, lower specific CO2 emissions, and even higher productivity in the case of mobile equipment. So in total, despite having higher investment costs, the total cost of ownership will be reduced due to the fuel savings and due to the extended drain interval. And with that, I would like to close my presentation. I would like to express my thanks again to Selçuk Akad for inviting me having this presentation. And I would like to thank the audience for the attention. Thank you very much.
I would like to thank Dr. Holger Pletsch for sharing all this valuable information with us. The slides that showed the amount of energy saved in the field of tests and uses under the real-world conditions were quite gripping. The energy saving potential that we can have when we use the right hydraulic fluid is definitely significant. Besides, using the right energy efficient hydraulic fluid not only brings us saving potential, but also increase in performance and decrease in downtime maintenance costs. Yes, now I want to get some questions from the participants, and let me browse through the questions we received via our social media accounts. And let's ask this first question. So, Dr. Pletsch, the first question is, do I need to follow a special procedure when I replace my current hydraulic fluid with an energy-efficient hydraulic fluid? Mm-hmm. Anything else I need to consider for the fluid change, please?
Okay, Selçuk, thanks for the question. I would say the replacement of a conventional hydraulic fluid with an energy-efficient hydraulic fluid does not require any special process or any special knowledge. In general, the oil change procedure is not different from any other oil change procedure. And also, it's important to emphasize that energy-efficient hydraulic fluids are fully compatible and miscible with conventional hydraulic fluids.
Dr. Pletsch, thank you very much for your answer. And our next question is, are energy-efficient hydraulic fluids available in all viscosity grades? In your presentation, I have only seen ISO VG32 and ISO VG 46. So what about ISO VG 68? Is the effect the same in all viscosity grades, please?
Okay, yeah, that's a very valid question. Yes, energy efficient hydraulic fluids are available on the market in all typical viscosity grades, including ISO VG 68. The working principle behind stays the same. A high VI and a good shear stability will avoid fluctuations in viscosity, and therefore keep the viscosity in balance. This is the key requirement for all hydraulic systems to work efficiently. And this holds true for low viscosity grades such as ISOVG 32, and also for high viscosity grades such as ISOVG 68. Yeah.
Dr. Pletsch, the information you share is very valuable. And your last question is, suppliers of modern injection molding equipment advertise energy efficiency as well as regardless of hydraulic fluid type. In such a case, how much difference can the choice of hydraulic fluid really make? Please.
Yes. I mean, modern hydraulic machines are engineered to be as energy efficient as possible. So for sure, the equipment design has a certain impact on the efficiency potential of the hydraulic system. But there are many, many other parameters that would define the final efficiency of a hydraulic system. And that is, for example, the operating temperature or the operating environment or the work cycles that are used. The key principle of energy efficient hydraulic fluids is to maintain the viscosity as constant as possible. And this principle allows for energy savings and therefore cost savings. And this is largely regardless of the hydraulic equipment that is used.
Thank you very much, dear participants. This is the end of our webinar today. Our speaker was Dr. Holger Pletsch, Technical Service Manager at Oil Additives business line of Evonik, one of the largest German chemical companies. I would like to thank Dr. Holger Pletsch for sharing important information and about the data, energy efficient hydraulic fluids. And thank you for participating in this webinar. Hoping to see you in our next webinar. Goodbye.